I'll show you, hang on. So on the board, I asked you to pick up your scrap paper, so everybody's gonna need a piece of scrap paper. And then I asked you to open to page 30 of your packet. This is the notes. These are the steps for drawing a profile. Then I said to do questions 75, 77, 78. You'll notice I highlighted them for you on this paper. And the directions say, base your answers to 75 through 78 on the topographic map below and your knowledge of earth science. The map shows features and contour lines of the region of a proposed airport. Line AB is a reference line on the map. Points X and Y represent surface locations along the creek. Elevations are shown in feet. Question 75 says on the grid in your answer booklet. If you didn't notice, it's on the back. And just like last time, I noticed I did not make it big enough. So you may notice that the lines off to the edge look a little weird. That is because during third period, I grabbed Kat's pencil and made the lines go all the way to the edge. Ignore the dot right here, okay? That's the wrong dot. Ignore that dot when you are making your profile. Then again, you're skipping question 76, and you can do 77 and 78 right now. So I'll leave this here while you guys flip back to page 30, where the directions are, remember, in case you forgot. So there's the directions for drawing the profile that you're going to be doing on this separate sheet of paper that I just grabbed for you. If you walked in late and didn't get one, they're up front. Okay, just you worry about you, get your grade, your profiles drawn.
How are you doing?
Just do your work. So follow the steps on page 30 first.
I'm lost.
These are the lines I want to show you, not necessarily these. You really only care about that line and those lines. Step one. The first one is actually called today. These are the lines. First thing, you tell me. And you're going to going up or down. Does it technically matter? This line doesn't matter because he up there.
What?
So you're only
I'm
going
lost.
You're only going from A to B.
What?
So how, what?
What do you? I don't know how to do something.
What did you have? You forgot. 40. Yeah, 40.
Yeah. Because she's an orange. Like all 9 points with a line.
You have more rows.
Okay. So step 1, determine conflict. Just going by 20. Step 2, scrap paper along the line. Alright, so let's look at us contour intervals.
What are we doing here? What is your
orange?
Yeah.
500. 460. Alright. So now take your scrap paper
Label them before you move.
and place it on the line you're doing.
Looks like it should be.
Here's another folder here, somewhere to work. Each one, scrappy,
Now
gonna
mark
pick a
the
dot on the
dots.
grass.
Okay, be right
All right, what's step one?
and label A, label B.
Oh,
Yep, and right. Line.
Keep it, anytime a contour line touches the solid line. Okay. All the way across.
This card is a munch.
Yes. Now you label the other. Now we will mark each line as well. Okay.
Remember, Jack, it's only, you're going to be covering, you're covering this up.
Oh, yeah.
So that is the last time I'm going to tell you to stop.
Okay.
You're going to be removed if you keep it up.
Good.
So
Now,
you do this. So only label on the top. So you go there, there,
take it
there,
at the bottom, match up A to A.
Okay, and you're going on 118.
Now, this one is going how much? So we got. Perfect. So now, we're gonna keep this spacing that you have. Here. So that's, this one we actually do. That's what you do.
Every line that touches it.
Sure. Okay, did you determine the contour interval? Okay, good. So now write them in. On the map.
Yeah, it was more neat. It seems
Yes.
like it's not.
So this is
there
four
now,
hundred, we just do.
but it might be just like that.
Okay, so that's 400, what's this one?
Yeah.
We'll take a look, that's 400 feet, and that's 500 feet. What do you think, Kathy?
Okay, ready?
So that's 400,
You
so
go all
we'll
the way
list
across.
one.
And then this line,
Yep,
all
we
of
go
these
next
little,
right there.
yeah, label them up here so that you don't cover it up. Now you can see your label.
Yep.
Alright, what's the next step? You've only done one thing.
Mhm.
Do the next step.
Do it above the line here, so you can see. when you're doing it.
That's right. No.
Okay, yep, so now continue, what's this one gonna be with? Yep, so I can double side it. Right now, yeah. Now. No, you're fine. Yeah, that's fine. Now, at the elevation.
Here's your top.
Okay, perfect. Now, on back to your secret. What I do, sorry, go back. Always mark. Always mark off where A and B is, so X and Y where they do. No. Okay, yep, all right. Let's over. Line it up. Up the room. Yep, that was done. Yep, to maintain that spacing between the contour
You have
lines.
my question? Looking at this one? What I did up here shows that the land is flat and does not have a steep slope. So you wouldn't want an airport on a steep slope.
Right, AC.
No, reasonable direction describes the contour evidence that it's not enough for an airport of this size to be built at the proposed location. Proposed area for airport. That's not quite, I know what you're, but you're so close. But what about the,
So the.
I might be able to give you credit. I would like a better answer. Like if I really had to fight for it, I would. Oh, what do you mean there's no line there?
It could be flat line.
Why would it be flat line again? What about the contour lines means it's a steep hill?
If they're like going, if they're going down.
Okay, so then that's not it. Why don't you read back into our notes to find a packet, put back in your notes,
Just less.
so you find where it says contour
Oh,
line,
so-
like where a steep area is, or where it does. Read back in there. Where to start? So I would never mark them and then we would.
Do you mean like joking? Is that?
So how do you know what the place for your phone?
They're like, sort of, that lines are really close, but. Just do what you actually say, don't do extra, if you do extra and do it wrong, then it's wrong. Okay, so only ever do what I ask. That looks perfect except for this one over here. And even that you did really well, but it told you to go from A to B. B was here. Okay, so that's what I just said, keep two. If you do extra and the extra is wrong, I have to write it down. So only ever do what I ask you. Don't do it. This is never gonna get you extra points for you extra, and it's gonna give you a wrong. Okay, so just be very simple there. Okay, question 77. Okay, so I know some of you still have the other two questions to go, but I want to talk about the profile first, and then we'll talk about those other two questions to start with. So this is what the profile should have looked like. So it started at 400, and then it went up to the 500. There were two 500s. I want you guys to be careful here. I saw a few people, what looked like a little bit flat here. So a little bit flat at the top of the hill. Please make sure you curve that up. And make sure it's curved up so I don't have to squint or say, well, did they mean to do that? I want it to be clear as day that that hill went up and over the 500, but did not touch the 520. So make sure that that clearly goes over 500, but clearly does not touch 520.
And then the other mistake I saw some people, and I actually stopped a whole bunch of people from doing it. The directions, first of all, I saw a lot of people trying to do from X to Y. I saw some people going across the paper like this. Remember, the directions said from A to B. So don't do whatever line you want to do. Do the line they tell you to do from A to B. And on a second note here, this line over here, do we care about this line right now? We do not, because it only wanted from A to B. So make sure you only do what they ask you to do. Here's the thing. If you do extra on the regions and your extra is wrong, I have to mark it wrong, even if what you were supposed to do was right, but your extra was the only thing wrong. If it's wrong, then the whole problem's going to be wrong. And here's another thing that I just mentioned too. There's never extra credit on the regions. So don't do extra because your extra could be wrong and then you'd get the problem wrong, but you'll never get extra points. So just make sure you remember the number one rule of earth science, read all the words, make sure you do it between A and B, and that's it. I asked you to skip 76 for right now. Let's go to 77. So if you remember from the directions I read at the beginning, this was a map of an area where an airport was going to be put. So here's where they proposed an area for an airport. What about this map would make it a good place for an airport? Carter, what do we want for an airport? We want flat land. Not sure if you've ever realized this, but would you want to land an airplane on the side of a steep hill?
Yeah.
No, that's what helicopters are for, and they even like flat areas to land. Airplanes need a large flat area. These maps are good for showing us flat land, because how do we know that this is a good place, a good flat spot? Not because there's no lines. You can, no, not because there's no lines, but what about the lines? Right. So to correctly answer this, describe how the contour lines provide clear evidence that the land is flat enough. You would say contour lines are far apart. So I'm pretty sure, like I said earlier, I'm pretty sure I know what you mean, that there's no contour lines there, but I really want you to know what it means to be gentle, and that's that they're far apart.
I'm smart.
Okay.
Easy.
Identify the general compass directions towards which, so this one says towards which Chris Creek flows. They want to know where it's going.
Towards the lake.
Okay, but does that,
Downhill.
no, wait, what does the direction say?
Downstream.
No, what does the direction say? Compass direction.
South.
Is compass direction downhill?
No.
Is compass directions towards the lake?
No. It's going southwest.
Okay, so the correct answer would be southwest. But my question is, how do we know that? This was not on the
Because
regions,
it's not exactly down. It's not exactly.
but no, I want to know how you knew which direction it was flowing, Sarah.
I drew out the compass, and then if you follow like the creek.
Uh-huh.
The compass, it's going to the south, west, like in between.
Okay, but how do you know it's not coming from that direction is what I'm asking. How do we know which way it's going?
Because it's going into a lake.
Flows into a big valley.
No, guys, that's not how we know. Now, I never mentioned that. Guys, we don't know what's on this end of the creek. There could be a whole nother lake here. This could be a whole nother lake.
But whenever the-
Streams and rivers can go from one lake to another, or can go from a lake to a stream to an ocean. So I never said rivers flow or streams flow or creeks flow from lake to lake. What did I say?
That's what I know.
Okay, so as you can see, the elevation starts from 500. That means the lines are going down, which means that the creek is going down.
Okay, so streams flow, that's one way. Streams flow downhill. So we have the bigger lines here. So this one, for example, is 400, 380, 360, 340, 320, 300. So one way is we know streams flow downhill. What's another way we can figure this out? Notice the bends, guys. Every time this creek crosses the lines, see how the bends are? But how can I describe this? So that, and what did you, I might have cut you off. Okay, so I think you've got it, but the easier way of thinking about it, so see how they point that way? Like the bends are pointing that way. See the V almost pointing that way? They point to where it came from, which I think is what you were trying to say. The easier way of saying it is that the water comes out of the bend. So see how the V's are making a shape like this? The water comes out of the V. All right, now question 76. I told you to skip it. Calculate the gradient along Chris Creek between locations X and Y. Label your answers with the correct unit. So first of all, we've got the word calculate. What does that mean to you?
Math.
Math. In this class, what do you know about math?
We don't do it.
We do it. We have our reference table. In fact, everybody just open up towards your reference table. You don't have to get it out. Because it is on the front cover and you won't need it other than to look at the reference table. So let me grab one here. So when we do math, your gut instinct is anytime that you have to do math in science class is to find the equation on your reference table. So there is a gradient formula. Change in field value divided by distance. So right on the top of page 34, we're going to start here. Right on the top, I would like to squeeze in that gradient formula. Let's do it right here. So gradient equals. And we're just going to copy this off of our reference table. Change in field value. What the heck is a field value? This is page 34. Change in field value. What the heck? Let's go back to when we used the word field before. What did I mean for a field? A field is this. This is a field. It's a map of whatever the map maker chose. It's like the view. It's whatever you see there. Now the field value is whatever is being measured. So in this case, we're measuring elevation. But remember, we can make these maps for temperature or pressure or numbers of aches and pains or numbers of pumpkins people own. You can make these maps for anything. So it's a change in whatever's being measured divided by distance. And again, I got that straight off my reference table. But before we go ahead and do this math, I want to actually ask you a question. Do you have any idea what the word gradient means? No. So some people, landscapers might know this. People who pour concrete driveways or blacktop driveways or work on roads might know this. They might refer to it as a grade though. Does that help anybody here? If you grade your driveway?
Grade? Like G-R-A-D?
Level, what do you mean? I think you're right. Okay, I think you're right. Okay, I think you know what you're talking about, but I'm not sure. Keith, does that like help you at all? Yeah, it's how level or how flat an area is. What do we call that? In like normal person talk, we don't call it a gradient. If we talk about how level the land is. Okay, I'm getting at the slope of the land. No one said, you wouldn't think it, like if I said it has steep slope, like you wouldn't automatically think like this. No, okay, well, now you have to. Okay, now you have to. So let's make sure we do think that way, and let's put a few little bit of notes. So gradient, this is another word for slope. Now you guys know slope from math class, right? Not the formula. I don't like the formula because that's a graph, but you know,
Ski slope.
like a ski slope. That's a perfect way. A ski slope is perfect. Or slope,
Ski.
if we're talking about the slope of a graph, it's whether the graph goes up really fast or not really fast. Officially, it's how quickly the value changes. Sorry, I just had to squeeze that in there, changes. And we talked about this the other day. If we have a steep slope, doesn't the elevation change really rapidly? If we have a gentle slope, the elevation changes really slowly. So we already know how to look at a map and tell this. If the lines are close together, it's steep. If the lines are far apart, it's a gentle slope. Well, now instead of just saying steep or gentle, we're going to give it an actual measurement and tell us how fast, like an actual, how many feet per mile does it change? What?
It's supposed to snow tomorrow.
Oh, you are not focusing.
Thank God.
Back to slope. So there's a formula, and I'm going to tell you, so I know some of you get nervous when you hear about math and science. It's not so bad.
It's,
It doesn't. This won't. There are things that will. This one won't. This one's not so bad. So if you follow these steps, you will be golden. Step 1, are you ready for it? Determine the contour interval and write it in for each line.
already have this written.
Oh, does that sound familiar?
Do we have to write it in again?
This is the only one that's the same. So yes, for this one it is.
Oh. Easy.
So Carter was super quick on that one and picked up that it's the same first step. So that's super helpful. Well, maybe not helpful, but it's not really that big a deal. I'll show you why once everybody's done writing, sorry. So determine the contour interval and write it in for each line. The fact that it's the same first step makes life easy because just like this question I just did with you guys, if they ask you to do a profile, the next question is probably going to be doing a gradient. So you probably already have it done. So step 1's not a big, huge deal. Step 2 is where we start using the formula. So again, the formula is change in field value divided by distance. So the first thing we better do is figure out the change. Yes, figure out the change. How do we figure out the change between 2 points? No. How do we figure out the change between 2 points? Find the difference. This really means find the difference. Sorry. In math, what does difference mean? Subtract. So since we were going to be using this one here, subtract X and Y, you just use whatever points they are talking about. This is the change in field value. So when you subtract, you found the change in field value. So did we find the gradient? No. We've only found the top number in the gradient formula. The bottom number, if we go back to what the formula was distance. How will we find distance on this map here that we were just looking at? How will we find how far apart points X and Y are? Nope, when we subtract, we get the difference in elevation. We did this the other day. This scale. We'll use the miles to find, or use the scale to determine the distance. So here I have it written as measure the distance between the 2 points using the map scale. I haven't even looked yet, sorry. Thank you, though. I mean, I'm sure it's probably right. And again, for the formula, this is the distance. Step 4 is going to be write the formula for gradient. Gradient. Now I know we already had it at the top of the paper, but I would like you to write it in one more time. Step 5, plug in numbers and solve. Change in field value, if you noticed, is really our step 2. Divided by distance was our step 3. And that will give you the gradient. And guys, here I'm going to give you a hint. Units matter. What are the units for step 2? If we were doing the difference between the 2 points, the change in field value. In this case, they're feet. So on our map, they're going to be feet. They could be meters. What's the distance measured in? Miles. For ours, it's miles. On other ones, they might be in kilometers. So right there, you've got the units. Feet per mile or meters per kilometer. Let's try one of these. We have the one we were just working on page question 76. Step 1, determine the contour interval and write it in for each line. So 300, what's the next line up past X? Okay, remember they counted by 20, 320, 340, 360, 380, 400. Okay, perfect. So step 1 is to determine the difference between those. No, the difference between point X and Y. So what was point X? X equals 300. Y equals 400. So if you subtract 400 minus 300, you get 100 what? Feet. So again, X was 300, Y is 400. When you subtract 300 minus 400, you get 100 feet. How do we use the map scale? Yeah, the map scale to figure out how far apart they are. Scrap paper, good news, you already have scrap paper. It could though be any sheet of paper you have. Remember, there's nothing fancy about this. Now, I've seen people do this 2 different ways. Do it my way, it's better, I swear. It's easier. Put your paper along X to Y. Mark off where X is, mark off where Y is. Now what? Put that on the scale. Mine came perfectly at 2.5 miles. Plug that into the equation. Gradient equals change in field value divided by 100, or divided by distance, sorry. Which number goes on top? 100 feet divided by 2.5 miles. I know you shouldn't do this, but grab your cell phones because I forgot to tell you to go and grab a calculator. If you want to go grab a calculator, you can. So when we plug 100 divided by 100 divided by 2.5, I also got 40. 40, what are the units? So notice I kept them as I was doing the problem. I kept them in the problem so that I could see right there, feet over miles. That means feet per mile. So guys, what this means is as you drive down the road, for every 1 mile you go, you will have gone up in the air 40 feet. So every mile, your elevation changes 40 feet. That's a pretty big difference. But just keeping it like that, that's all you gotta do. So we've got now literally everything they will ask you about contour maps. You know how to draw them, you know how to read them, you know how to make a profile, and you know how to make a gradient. You have learned all there is to learn from chapter 2. We will practice some more over the next few days, but as you can see on the board, there is another test on Thursday. And for the record, your homework is page 33, which is to do a profile. There are no directions there. It should say draw a profile from A, oh, well, here, A to B. It's just a little, it does come out really little.
Oh, I did the other side. I did this side. Oh, okay.